So hello everyone, my name is Rex Adrian Arabon. In this video, we will be talking about raw and percentage scores. So wala nang intro, let's go diretso. So now let's define what a raw score is. So to put it simply, raw scores are the total numbers of correct responses in a test. So for example, 8 over 10 or 36 over 50. Another example is you took a math test and got 30 out of 40 items correctly. Now, obviously, your raw score would be a score of 30. So this means that you got 75% of the total items correctly, which is the percentage score. Now, percentage scores are important in describing a student's performance based on a criterion or a principle of judging. In obtaining the percentage score, all you have to do is to take your raw score, divide it by the total number of items, and then multiply by 100. Let's go back to our example where we got a raw score of 30 over 40. Now our raw score is 30. We divide that by the total number of items, which is 40. And then we get an answer of 0.75. We take that 0.75 and multiply it by 100. In that case, we get an answer of 75, which is your percentage score. So for us to be able to understand the lesson more, here is another example. Chris got a score of 64 out of 80 in an assessment. So we take his raw score of 64 and divide it by the total number of items, which is 80. So 64 divided by 80, we get an answer of 0.8. And we take that 0.8 and multiply it by 100, and we got a percentage score of, you guessed that right, he got a score of 80%. And that was raw and percentage scores. Not too bad, right? Now, let's proceed to another type of test scores, which is the percentile rank. A percentile rank gives the percent of scores that are at or below a raw or standard score. So basically, it just indicates the percentage of scores in the distribution that fall or at below that particular score. So in native tongue, kung gisayon gani nato class, ang percentile rank maghahatag na siya og percentage of scores that are at or below a given standard score. So below ra gyud iyang ihatag nga percentage. Di na siya maghatag og percentage of higher than that standard score. Below lang yun. For example, a score of 35 or a standard score of 1 falls in the 84th percentile, which means the student scored as well or better than the 84% of the students in the sample. We could also say that the student score is in the upper 16% of the norm group. If there were 200 students who took the test, a percentile rank of 84 indicates that the student scored higher than 168 students. So to ease our understanding, here's another example. A score of 20 is in the 25th percentile. This means that 25% of all scores are less than 20. If there were 100 individuals who took the test, 25 of them had a score of below 20. This would also mean that a number of 75 individuals got a score of 20 or higher. And that will be it for me, class. The other types of test scores will be discussed by my groupmates. I really hope that you learned something. This will be the end of this video. Goodbye and God bless.
Hello everyone, I am Brisa Maypidache and I am going to discuss the topic about standard score and Z-score. It is truly difficult to use raw score when making comparisons between groups or and different tests considering that the tests may have different levels of difficulty. But in order to solve that problem, a raw score may be transformed to a derived score. So what is a derived score? Derived score is a numerical description of an individual's performance in terms of norms. So there are two types of derived score. The first one is the scores of relative standing, and the second one is the developmental scores. Now, a standard score is a derived score in which it utilizes the normal curve to show how a student's performance compares with the distribution of scores above and below the arithmetic mean. The row scores above the mean have positive standard scores, while those below the mean have negative standard scores. So this score has been transformed to fit a normal curve with a mean and standard deviation that remain the same across ages. So this is a normal distribution and scales. The normal curve here represents a normal distribution. So as we can see, the left and the right side are symmetric to each other. So this normal curve is a symmetric theoretical distribution. The mean, which is the arithmetic average, median, which is the score that separates the upper and the lower 50%, and mode, which is the frequent occurring score, is located at the center curve. Because the mean and the median are at the middle, it is expected that half of the test scores are below the mean and half are above it. The mode indicates that most scores are average level. So there is an empirical rule which is 68, 95, and 99.7 rule, and this rule shows the connection between the normal distribution and the standard deviation. Under this rule, 68% of the data falls within one standard deviation, 95% within two standard deviations, and 99.7% within the standard deviation from the mean. Now let's go to Z-score. Z-score is a standard score which gives the number of standard deviations of a test score above or below the mean. It tells us how many standard deviations from each value lies. The formula of Z-score is Z equals to X minus mu over sigma, where X is the individual value, mu is the mean, and the sigma is the standard deviation. I think most of us here are familiar with this, I assume. So a positive Z-score means that your X value is greater than the mean, while a negative Z-score means that your X value is less than the mean, while a Z-score of 0 means that your X value is equivalent to the mean. So Z-score is very useful statistics because it allows us to calculate the probability of a score occurring within our normal distribution and enables us to compare two scores that are from different normal distributions. So let's go with Z-table. So the picture presented here is a Z-table. So Z-table is a mathematical table that allows us to know the percentage of values below a Z-score in a standard normal distribution. To use the Z-table, first you need to go down to the row with the first two digits of your Z-score. Then go across to the column with the same third digit as your Z-score and find the value of the intersection of the row and column from the previous steps.
Teacher in high school giving some tests, then I will be scoring there up to top night. Now we gotta figure out how to do it right. So much to check and score. Up in the classroom with my student family, in a room where students are so smarty. The whole intelligent class are waiting their scores. They're so excited to see. I'm finding out what the scores are all about. It is a way to give grades effectively. It's gonna be useful to utilize data using TScore.
Okay, so good afternoon everyone. I am April Macy Tabancora and I will discuss the T-score and standing score. Okay, so T-score. The T-score is the test statistic used in t-test and regression test. So in finding or solving the t-test and regression test, we will use the t-score. It can also be used to describe how far from the mean an observation is when the data follow a t-distribution. So in other words, ang t-score is equivalent to the number of standard deviations that away from the mean of the t-distribution. Transform z-score into t-score. So, from z-score, ato siyang i-transform into t-score. In solving t-score, we will need the result of the z-score. Much like converting Celsius to Fahrenheit, which follow a distribution with mean is equals to 50 and standard deviation is 10. Okay, so in finding the t-score, the mean and the standard deviation is already given. And in converting z-score into t-score, the formula that we will use is t equals 50 plus 10z. Okay, so I have here an examples. So example 1. 3 is our z-score. Okay, so t is equals 50 plus 10 and substitute 3, and then so 50 plus 10 times 3 is equals to 30. So 50 plus 30 is equals to 80. So 80 is our t-score when our z-score is 3. Example number 2. Our z-score is 9. So t is equals 50 plus 10, then substitute the 9. So 50 plus 10 times 9 equals to 90. So 50 plus 90 is equals to 140. So the next or the last example is our z-score is 1.60. T is equals 50 plus 10 times 1.60. So 50 plus 10 times 1.60 is equals 16. So 50 plus 16 is equals 66. Our t-score is 66 when 1.60 is our z-score. Okay, so next is standard score or standard 9. It is a way to scale scores on a 9-point scale. It can be used to convert any test score to a single-digit score. So it is a method for scaling test score from 1 to 9, which 1 is low, then the mean is 5, and 9 is high. So standard scores are standardized scores on each dimension for each type. So since standard score can be used to convert any test score to a single-digit score, pareha ni z-score o ni t-score, ang standards or standard scores are a way to assign the number to a member of a group. So relative to all members in that group. It calculates how much a result varies from the average or mean. In standard scores, the mean or average is always 5 and the standard deviation is 1.96. Convert into 2. Just like t-score, ang mean and the standard deviation is already given. No, so the formula that we will use in solving standard score, SS is equals to Z plus 5. I have here an example. Our Z-score is negative 1.5. Okay, so SS is equals to 2 times negative 1.5 plus 5. So, substitute si negative 1.5. Okay, so 2 times negative 1.5 is equals to negative 3 plus 5. So, negative 3 plus 5 is equals to 2. Okay, so, our standard score if negative 1.5 is our z-score is 2. So, 2.5 ang ato ang z-score. So, 2 times 2.5 is equals to 5 then plus 5. So, 5 plus 5 is equals to 10. So, our standard score is 10. If 2.5 is our z-score. So, last example is z-score is equals to 1.5. So, 2 times 1.5 is equals to 3. So, 3 plus 5 is equals to 8. So our stunning score is 8 if the Z-score is 1.5.
Hi everyone, my name is Riva May O. Torres, and today I will be explaining to you what is a normal curve equivalent and what is a development score. But first, let me explain to you what is a normal curve equivalent. A normal curve equivalent, or the NCE, is a normalized standardized score with a mean of 50 and a standard deviation of 21.06, resulting in a near equal interval scale from 0 to 99. The normal curve equivalent, or NCE, was developed by RMC Corporation in 1976 to measure the effectiveness of the title program across United States and is often used to measure gain over score. So in a normally distributed population, if all students were to make exactly 1 year of progress after 1 year of instruction, then their normal curve equivalent would be 0, even though their raw score, or the number of questions they answered correctly, increased. Some students will make more than a year's progress in that time and will have a net gain in the normal curve equivalent score, which means that those students have learned more, or at least have made more progress in the areas they are being tested than the general population. The normal curve equivalent is a way of measuring where a students fall along the normal curve. The number of the NCE line run from 0 to 99. It is also somewhat similar to percentile ranks, which indicate an individual student rank, or how many students out of 100 had a lower score. The NCE is preferred by some because of its equal interval quality. Scores differences between tests and among subtests in a test battery can be calculated and examined. For my next topic, we have here the development score. Development score, or a grade equivalent, or GE, describes a learner's development growth. It gives a picture as to where he or she is on an achievement continuum. It is called a grade equivalent because it uses grade of school like second grade, third grade, fourth grade, and so on, as a scale and measurement of a student's advancement. So the GE is expressed as a decimal number, like 4.8, for example. The 4-digit to the right of the decimal represent the month. The 8-digit also represent the grade. So we assume 10 months per school year. So the grade equivalent of a given raw score on any test indicates the grade level at which the typical student earns this raw score. For example, if a 7th grade student earned a GE of 8.4, it means that the student's raw score is like the raw score the typical student would likely earn on the same test at the end of the 4th month of the 8th grade. We also have here another example. A 4th grader could receive a 6.3 of a grade equivalent. So this does not mean that this student can perform immediately the 6th grade content. So the 4th test does not contain any 6th grade content, nor has the student been exposed to any 6th grade content. This score simply means that on this particular day, this student performed much better than the average student performed on test. Take note that it is important to realize that GE scores outside a particular student's grade are common and should be interpreted cautiously. That would be all for my topic. Thank you.
Good afternoon, everyone. I am Jira Ut, and at this point, I will be discussing about Criterion reference interpretations. So, the second type of test scores interpretations are the criterion reference interpretations. The word criterion came from the Greek word criterion, which means standard. Criterion reference interpretations provide meaning to test scores by describing what the learner can and cannot do in light of a standard. So basically, criterion reference interpretations mean you versus criteria or standards, or your score versus the criteria, or it can be achievements of individual is compared to the criteria. Say for example, the LAT exam has a criteria of 75%. If your score is 72%, it means you are below the criteria. Or, if your score is 85%, it means you are above the criteria. It can also be achievements is determined by the distance of his or her score from the criteria established. Again, the LAT exam, say for example, has a passing rate of 75%. If you got a score of 85%, it means that you are 10% above the criteria. On the other hand, if you got a score of 74%, it means you are 1% short of the criteria. Furthermore, scores in tests allow for absolute interpretations and not comparative. In relation to a predetermined criterion of mastery, performance of a learner is explained. Performance is interpreted by describing what the student can do, meaning passed, and cannot do, meaning failed, with respect to the criteria or standards. Or, in criterion reference interpretations, it's simply pass or fail. Your performance versus the criteria. It's either you passed the criteria or you failed the criteria. This is also used to determine learners' mastery of knowledge and skills. Scores are simply on the criteria or above the criteria and below the criteria or standards. If you are on or above the criteria, it means you passed. If you are below the criteria or standards, it means you failed. So aside from the mastery tests, the following assessments can also generate criterion reference interpretations. Number 1, teacher-made tests. Examples of these are matching items, fill-in-the-blank items, true or false questions, or essays. Number 2, skills test. Skills tests include immersive experiences such as coding challenges, job simulations, or mimic how a candidate performs when faced with real-life scenarios. 3, competency test. Example is competencies that describe the knowledge and skills required for nursing practice are used to develop competency tests for the registered nurse exam. Number 4, performance assessments. Examples of these are conducting a laboratory investigation, making a research paper, or simply group presentations or performances. And the last is number 5, licensure examinations. Examples of these are licensure examination for teacher, for nursing, for criminology, etc. In diagnosing needs of students and monitoring their progress, criterion referencing is utilized. Likewise, it is used in certification and evaluation of a program. It is the preferred assessment mode in an outcome-based education framework. Here are the advantages of criterion reference grading system. 1. It is an ideal system to utilize in collaborative group work. 2. Students are free to collaborate with the instructor and with one another. 3. A learning environment which is rich is the advantage of everyone. Number 4, students are rewarded for finding ways to assist each other. 5, students are able to compete with their own previous performance rather than with other students. 6, grades of students are based on their own performance rather than be associated with their peers' performance. 7, for a given outcome, students have a definite and clear understanding of standards required. Number 8, students are able to exercise greater choice and judgment in the outcome level they target. And lastly, number 9, outcomes of students are based on demonstrated competence rather than arbitrary and temporarily conflicting standards.
For us to learn ay dapat gets mo, gets ko at gets natin to with your baguette speaker, Mr. Hubert A. Torrentira. Good afternoon everyone who participates this virtual symposium. It is my honor and great privilege to be one of your resource speaker in this significant event. This afternoon, I will make sure na dapat gets mo, gets ko at gets natin to this topic that I will be presenting to you. At wala nang pagpaligoy-ligoy pa, let's talk about the norm reference interpretation. What is norm reference interpretation? Mr. Baguettes, gets mo ba? Norm reference interpretation is one of the type of TScore interpretation which main aim is to measure the hinges on the purpose of assessment. The term norm originated from the Latin word norma, which means precept or rule. By this definition, it is pertaining to the average test score and the test. What is the main function of norm reference interpretation? Norm reference interpretation compare a student's scores to a range of previously observed performance, usually the performance of other students. How much the student knows is determined by his or her ranking or his or her position in a norm group or the group of reference. For example, we will rank the 6th graders. Remember, if we will rank the 6th graders, only 6th graders are included. Other year levels are excluded because 6th graders is our group of reference. And another purpose of norm reference interpretation is to discriminate the high and the low achievers. Because, of course, we are ranking these students who got higher score and the lower score. What's more on about norm reference interpretation? We will always remember that the percentile rank and the standard scores are common in the norm reference interpretation. Remember, the percentile rank and the standard scores are common in norm reference interpretation. For example, to say that a child placed 8 in a reading class. So in this example, we can say that we are ranking the performance of this child compared to the performance of his or her classmate or the persons within that group of reference. So maybe there's 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 9th, 10th, or 4th and so on in that particular group of reference, and that child is in the 8th place. Then we are ranking the performance of the child. Another is the child's score in a reading assessment at the 85th percentile. So remember that this means that the child scored better than the 85% of the students in the group. So we are using the standard scores and the percentile rank in the norm reference interpretation. What are the assessment instruments using norm reference interpretation? The screening, diagnosis, and the outcome assessment are interpreted in a normative fashion. The standardized aptitude and achievement test, the teacher survey made test, the interest and adjustment inventories are also part of it. We are using the norm reference interpretation in interpreting the scores of the students who take the test. And we will always remember that in using the normative fashion, we were able to differentiate the students because we are ranking them based their performance in relation to the performance of others. And at the same time, the school can determine what are those necessary things required or needed for the students with their particular ranking or position within the group of reference. What are the guidelines in interpreting norm reference test scores? According from Netco and Brocard 2011, there are 5 guidelines in interpreting norm reference test scores. First, detect any unexpected patterns of scores. As teacher, we need to look out for unusual, especially the extreme scores. If the student's test scores does not confirm on our observation to the particular student, then we need, as teachers, to reflect on our instructions. That's the first one. Next is determine the reasons for score patterns. So we cannot deny that there are factors why the students are underperforming in the subject or other subject and any subjects. Maybe it's because they have learning disabilities. If we remember the dyslexia, dysgraphia, dyscalculia, and many more. Or simply, they are just lack of motivation. So we need to determine that reasons. That's number 2. And number 3, do not expect surprises for every student. So as teachers already observe the students, we already know, we already observe the pattern, the trend of their, the way they perform, their performances, or their test scores. So we do not need to expect beyond on that, because we already know how the students perform in the class. Number 4, small differences in subject scores should be viewed as chance fluctuations. The different test scores will be or may not subject for any intervention. Example, these test scores have greater difference compared to others which have lower. But still, our intervention depends if we really meet the objectives we targeted on a particular assessment or the topic that we assessed. And last one, use information for various and observation to explain performance on the assessment. So example, it is not shocking for us teachers who already know that students is not good or poor in writing Filipino and English to have low score in essay writing, of course. I guess that's the content of my presentation this afternoon. I hope that gets more, gets go, and gets not into the topic that I already presented to you. I hope that you learned something. Thank you and God bless everyone.
A wonderful day, everyone! Welcome to our quiz game. This is Jerely Sagbang, your game master for today. And now, let us test your knowledge and understanding in this word jumble game. Here's the mechanics. Rearrange the jumbled letters into word or words in order to arrive at the correct answer. Images are also provided as a hint. Are you ready? Let's begin!
Round 1. Time starts now. Time's up. The answer is assessment data. It provides a means to look at student performance to offer evidence about student learning in the curriculum. Round 2. Time starts now. Time's up. The answer is raw scores, obtained by simply counting the number of correct responses in a test following the scoring directions. Round 3. Time starts now. Time's up. The answer is Criterion Reference Interpretation. It is designed to measure the performance of the students compared to a predetermined criterion or standard. Round 4. Time starts now. The answer is percentage scores. It is obtained by dividing the raw score with the total number of items and multiplied by 100. Round 5. Time starts now. Time's up. The answer is norm reference interpretation. It compares a student's score to a range of previously observed performance, usually the performance of other students. Round 6. Time starts now. Time's up. The answer is standard score. It is a derived score which utilizes the normal curve to show how a student's performance compares with the distribution of scores above and below the arithmetic mean. Round 7. Time starts now. Time's up. The answer is ZScore. It gives the number of standard deviation of a test score above or below the mean. And for the final round, round 8. Time starts now. Time's up. The answer is percentile rank. It gives the percent of scores that are at or below a raw or standard score. Did you got perfect?
Ladies and gentlemen, thank you for your participation. I hope you learned and enjoyed the quiz game. Once again, this is Geraldine Sagbang. Have a nice day, everyone.